Let's try that one. So 5x plus 8 is 13. So there's the wall. X is saying I want to be alone. So now this section, we're going to have to do more than one step. These problems are going to be larger ones where you don't just do one step like we did in the last two sections. You're going to take more than one step. So X is over there saying I want to be alone. So what should you do to get X alone? Let me give you some steps for equals problems. Steps for equals problems. Number one, if you have fractions, multiply all terms by LCD. If you have fractions. Step two, do your adding, subtracting. Last step, divide. So that's an order to help you. A lowest common denominator. Yeah, common denominator. So we don't have fractions yet, but in a minute there's going to be fractions. So here's the steps that'll that'll help do this. So what's my first step there?
Can't you do subtract 8 on both sides?
Yeah. So yeah, X is, here's the wall. X is over here saying, I want to be alone, right? X is saying, I want to be alone. Get rid of this 5, get rid of this 8. How do you know which one you do first? Well, it's kind of like peeling an onion. How do you peel an onion? You don't start in the middle. You start in the outer layers and you work your way down to the middle. The X is the middle. X is the thing we want to get alone. So start with the thing furthest away from the middle, furthest away from X. That'd be the 8. Right? The 5 is close. The 5 is real close. Save him for the end. He's right next to X. We'll get rid of him last. First, get rid of the thing further away. Get rid of the 8. I'm not even thinking about the 13. He's the other side. I don't have a problem. X doesn't have any problem with the 13. X wants to get rid of the 5 and the 8. The thing's with him on his side of the wall, right? So which one first? The 8? How do we get rid of that 8? What will get rid of that 8? Subtract. That's what I mean by do adding, subtracting first. Dividing last. We didn't have any fractions on this one, so we'll be skipping step 1 for a few problems here. So subtract 8 from both sides, and then we get bring down the 5x, and that's what, 5? Good to there so far? Now X is still saying I want to be alone. What's the last step on every solving problem? Divide. And whenever you divide by the very same sign. In fact, you could just say it's the identical twin. Same sign, same everything. Whatever's next to X, just divide by exactly that. Same sign, same everything. Divide by the identical. So I'll just say divide by the identical. So that cancels. 5 over 5 is 1. There's our answer. Good on that one? 2 steps there. Okay, so 2x minus 13 is 5. Here's the wall. X is saying I want to be alone. So do whatever it takes to get X alone. So what's the first step to get X alone? Add that 13. Got to do it to both sides. So bring down that. That'd be 18. Yes. So, and what's the last step in every problem? Solving. And divide by the identical twin. Exactly what's there, right? So X is 9. Is that good? Is that really the answer? Yeah, if you go back to the beginning, if you put 9 in right in the beginning here where the first question was, if you made that 9, 2 times 9 would be 18 minus 13. Yeah, it's 5. 9 really is the number that makes the equation true, isn't it? That's what we're finding. We're finding the number that would make the thing true. If you're just a really good guesser, you could just guess at it. But that'd probably be hard to do. All right. Let's try that one. So 7x plus 13x is 160. Yeah, notice those both have x's. Let me write a couple instructions. X's on the same side combine like terms. So yeah, those x's are on the same side, aren't they? So we just add them up. So 7x and 13x, 20x. We good there so far? And now, hey, and it doesn't become x squared, does it? When did they become x squared? If that was times, right? It's not 7x times 13x, is it? It's just added. So you just add the numbers in the front, keep a regular x. All right, now x wants to be alone. So what are we going to do to get x alone? What's the last step always? Divide by the identical twin. Same sign, same everything, exactly what's next to x. Boom, x is 8. Now we're good. We good on that? Okay, so 6y minus 4 is 23 minus 3. Here's the wall. Now, this time, instead of having the letters on the same side, the letters are on opposite sides. So let me write some instructions for that. If the letters are on opposite sides. So remember, if you look back, see this last problem? See how we had the two letters on the same side of the wall of the equal sign? And in that case, you just combine like terms when they're on the same side. But now they're on opposite sides of the wall, aren't they? Left side, right side. What do? You do the opposite of one of them to both sides. You get rid of one. So basically, you get rid of one of them by doing the opposite. And you do it to both sides, because you got to do whatever you do to both sides. So as I look at the two y's, I say, okay, I don't want them on two sides like that. I don't want one on the left. By the way, I'm not even going to think about the minus 4 and the 23 right now. Later for that. First the letters. Always first the letters. So what am I going to do about those letters? Well, those are on opposite sides. So that means you get rid of one of them by doing the opposite. It doesn't really matter which one. I usually, out of habit, do the lower one, but you don't have to. So the lower one's the minus 3y. So I'll go to him and I'll do the opposite. What's the opposite of this guy? Be positive. Add. Yeah. Add 3. See how that's going to cancel him out to do that? Whatever you do to one side, you have no choice but to do the same thing to the other, because you're keeping the balance, right? They were equal before, treat them the same, still be equal.
Why didn't you put the 6y over there? Oh, you could do both? Oh, okay.
Well, yeah, so I could have. So when you see these y's on opposite sides, you've got to do the opposite of one of them. It doesn't matter which one, and then do that same thing to both sides. So I could have gone minus 6y and minus 6y, and that would have got rid of this one. But I decided I usually just get rid of the lower one.
Okay.
You don't have to do. You can get rid of the higher one. It doesn't really matter. So I'm getting rid of the lower one, so the opposite is plus 3y. So that does get rid of that one. It makes the other one, what's this, 9y? And now we've got the letter in only one spot. Now it's back to normal. So what's our next step now? Now we can just add 4, because y is saying I want to be alone. Add 4. So we get 9, bring that down. 9y is, what's that, 27. Last step, divide by 9, y is 3. Is that good on that? All right, they're getting... Okay, so let me write it up here. 6 minus 2x is 5x. Minus 9x plus 6. Okay. So this time you have a lot of x's, right? You have x's on the same side, x's on the opposite. So I would first combine those two x's on the right side. Combine like terms. So 5x minus 4, 9x is minus 4x. We good there so far? Just combine those two. Now, remember, it's x's first. Don't worry about the others. Just x is first. What do you do when you have X is on, now it's opposite sides of the wall. What do you do about X is on opposite sides of the wall? Do the opposite of one of them. Does that help your memory? So opposite sides, do the opposite, basically. So it doesn't matter which one. Technically, the minus 4x is smaller. He's more negative, but it doesn't matter. You can either add 4x to both sides or add 2x to both sides. It'll work either way. You'll get rid of one of them.
So can you do a positive 4x?
To both sides.
To both sides.
Yeah, because that'll get rid of the negative ones. Yeah. So that's what I'm going to do. I'm going to add. But if you added 2x to both sides, that'll work too, because that'll get rid of the negative 2x. It doesn't matter. Just get rid of one of them, and it'll all be good. I need one more note taker. Wasn't there somebody last time that said they were willing to be a note taker? Oh, great. Would you come up after class and I'll match you up? Thank you. All right. In a few minutes here. I knew I was going to forget that if I didn't say it. All right. So yeah, now I'm going to add 4x. But you could add 2x. It doesn't matter. You just got to do the opposite of somebody. Get rid of one of those x's. That'll get rid of that one. So then I get 6 plus 2x equals 6. Good to there? Now we're back to normal. X is in just one location. It's a little more regular. X is saying, I want to be alone. So what are we going to do? Subtract the 6. Boom. So we get 2x is 0. Yeah. Yeah, I'll show that in a minute. Let's finish this way first, and I'll go back that way. So we get to here. Now, you don't need to stop or do anything. Where just keep on going. Don't even let that 0 bother you at all. What's the last step always? Divide by whatever's next to x. And whatever you do to one side, do the other. Just keep right on moving. Do the same thing you would always do. Whatever's next to x, divide by the identical twin. And so what does that mean? X equals, now what is 0 over 2? 0. That's just 0, huh? Right? If you ate 0 halves of the pie, you ate no pie. It's 0. Just a weird way to say 0, isn't it? Yeah, now the other way, yeah, I will show that other way. The other way, 6 minus 2x is minus 4x. If you instead did the other way and added 2x to both sides, that's okay too. That would just get rid of this one. And this would be what? Minus 2x plus 6. And then you would subtract 6 from both sides. This would be 0. This would be minus 2x. Last step, divide by minus 2, right? We always divide by the identical thing next to x. 0 over anything, though, is still just 0. Doesn't matter, it's negative, whatever. 0 over anything is just 0. Same answer. It's all good. Math always works as long as we don't make a logical mistake. All right. Okay, so write that one down. They're getting messy. First thing we want to do on this problem is just get rid of all those fractions, right? Those fractions are difficult, so we want to get them out of there. So how can we get rid of all those fractions? First, step number 1, multiply by the LCD, common denominator. Yeah. You could and make that 8/3 x. That would be nice. That's not normally something that happens. This is kind of a weird problem. You could also make this a 20. That's just a nice 20. But that stuff doesn't normally, so I'm not going to do it because normally this is kind of a weird one. But yeah, you're right. If you know that, great. I'm going to pretend I didn't see it because it's not normally there, and I think I'll confuse people. Okay. But yeah, if you see that, great. So I'm just going to multiply through by 3. Every term. Notice that I multiplied even the 5x who doesn't have a fraction, who's not a fraction. Why? Because you got to do equal treatment. Complete equality to both sides. Right? We're keeping the balance, aren't we? If the left side equals the right side, and I do the same thing to all the terms on the left and all the right, they'll still be equal. That's the principle of equality. If two things are equal and you treat them the same, they'll still be equal when you're done. Okay, so I've multiplied through everybody by the 3. Here's the wall. What happens? Well, let me get this out of the way here. These are going to cancel. Remember, this is 3 over 1. All these are really 3 over 1, aren't they? 3 over 1, 3 over 1. Remember, whole numbers are over 1 when they interact with a fraction. So cross cancel. This is 7x plus these cancel, 1x. See how we're getting rid of the fractions? Is that okay so far on the left side?
Okay, so
Right, yeah, I ignore the ones in the bottom.
Okay.
Yeah.
And then there's a 1 over here. Right.
The 3's canceled, so it's just 1x.
One,
Now on the other side, 3 times 5 is 15x. Everybody see that? Because that 3 is the only 3 that's not canceled out by a denominator. All the rest are canceled out, aren't they? Like this one is canceled, so it's just 60. This one is canceled, so it's just 8x. No more fractions. Much nicer now. That's the most important step. Let me let you digest that step. Or go ahead and go on from there. But any questions on that step? Go ahead and move forward, but I'm glad to answer any questions you're having. That's the most important. Make it through there, you're probably fine.
Wait, so why did he multiply the 60 and 3 and 8 and 3? Why did he multiply the 60 and 3
Good, see what happened
and
there?
8 and
See how all those denominators were canceled out and
the
gone, so
denominators
no
are-
fractions anymore? That's what we want to do, is
See
get rid
the
of them.
denominators, we have to, when you do this, basically, the denominators, just don't pay attention to that, and just do it like 3 times 15 and 60.
Go ahead, now you can combine these two, 8x over here, and here's 15 and 8, with a 23x. Combine like terms to the left and the right. Very good. Yeah, negative 4 should be the answer. Negative 4? Negative 4 is the answer, I believe. All right, so 7x and 1x is 8x.
Yes.
15x and 8x is 23x.
Mm-hmm. 60.
So far, so good.
Can you go back and explain why you multiplied 3 times the 60 instead of 60 over 3? Someone was asking, so I just want to make sure
Yeah,
there's
so
an understanding of why you did it the way.
right here, so I gave a 3 to everybody.
Right.
So, and then that canceled out, so he was gone. So I was trying to get rid of all the denominators, so I gave a 3 in the top of everybody. Does everybody see that? The 3 went in the top of everything, or 3 over 1 if you want. That's what I mean by top. And then it cancels, cross cancels what's below. So those are just gone, and we just have 60 there. Is that making sense? And they were gone right here, and I just had 8x. And they were gone right here, and I said 1x. They were gone right here, and I said 7x. The only place the 3 actually multiplied was right there, because there was nothing underneath to cancel the 3. So he had his way and multiplied, right? All right, so now what do? We have x's on opposite sides of the wall. What do we always do with x's on opposite sides? Do the opposite of one of them. It doesn't really matter. It's going to be actually easier this time to get rid of the 23x. I'll show both ways, because that'll put the x's on the other side. Boom. And that'll be, what is it, minus 15x equals 60. So I'm going to bring it up here. So minus 15x is 60. What's the last step always? Divide by identical twin. Minus 15. Same sign, same everything. Exactly what's next to x, divide by it. So x is over here. Positive over negative is negative. Divide in your calculator, tell you 4. Negative 4 is the answer. Is that good? I'd like to practice a couple of those our last 15 minutes. Okay, so let me write it up here. 12 fifths plus 3y is 6y minus 1/10. I said feel free to bring your laptops, right? Get some of the homework done if you want in here. I would say that. Yeah, feel free to get some of these done ahead of time. While this is easy for you. You can get homework done while you're in here. Or your phone or whatever. Feel free.
That's
Okay, so this one, always fractions first. We got fractions, do them first. Always get rid of those first. What's the common denominator? 10, right. Does everybody see that? Because we have 5 and we have 10, and they both go into 10, don't they? 5 and 10 both go into 10.
So we put
10, 10, 10, 10. Top of all 4. That's what we always do with the common denominator. It goes top, 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 top. 10, 10, 10, 10. It's really 10 over 1, isn't it? 10, 10, 10, 10. Is that good? Now, why are we doing the 10 thing? What are we trying to make happen?
Common denominator.
Getting rid of fractions. We're trying to take out denominators, aren't we? So make sure you cancel denominators on this stuff. That's the 10's job in life. He's a hitman. He takes out denominators. I try to use weird words so it'll stick with me. So I'm not doing the Charlie Brown wall. Does that make sense? He takes them out.
Oh, okay, so,
Takes them out.
so do we cross cancel there?
Right. It's 10 over 1, so we cross cancel. So 10 over 1, 5 goes into 10.
2.
2 times. So you cross cancel, and whatever's left over multiplies. Remember, that's the job of the LCD. He's got one job in life. You know, I talked to a hitman in my office hours years ago. Sort of. I'm using the law. He was an official hitman. He was a government sanctioned hitman, meaning he was in the military. What's a hitman in the military called?
Sniper.
He was a marksman, a sniper. He was a sniper. Yeah, so he was an older gentleman. He'd been back in the Vietnam War. He'd been a sniper. Anyway, very interesting guy. Yeah, my son was taking classes at that time, and it was years ago, and we asked him, peppered him with a bunch of questions. Very interesting. He said he was a young man. He was like 65 10 years ago when I talked to him. And he said, I was just a young man. I joined the military, and I was good with the rifle on the range. I just happened to be good with the rifle. And the sergeant said, we're going to put you in a special school, young man. And they put him in a special school. He said, next thing I knew, I was in sniper school. And then they took a group of us up to a top of a mountain, and they would point to the bottom, and they would go, target. And those were human beings. And, he would anyway, he was an interesting, very interesting guy. Anyway, I'm going to tell too many stories. I'm just trying to help your memory. Hitman, right? Because why I'm saying this is because I've seen students over the years make this mistake. They'll go here and they'll go, 1 times 10 is 10. No. Remember what his job in life is. Right? So I'm trying to say what I can to help you remember the math. He takes out denominators. That's the very purpose of that. Yeah, question?
So 5 goes into 10
Right.
times.
Yeah, so let's finish that up. Okay, so he does his job here. Oh man, I'm erasing it. He takes out, 5 goes into 10, 2 times. So they're gone, right? You with me? They're dead. They're gone. They're out of there. They're not there anymore. What's left over multiplies. 2 times 2? 12. 12? I messed it all up, didn't I? All right, thank you. 2 times 12? 24. We good with that? So remember, the job of the LCD is to take out denominators. Let him do his job. Plus, now right here, there's nothing under here. A 1 if you want, but I'm not going to put that in there. There's no denominator. So what? So it'll just multiply. 30y. Is that good? So it takes out denominators when it can. That's the purpose. But otherwise, it just multiplies. Right? Right here, there's no denominator there. 6y and 10. There's nothing under the bar. So they just multiply. Now here, boom, took him out. Right? That's his job in life. Let him do his job. So all that's left is a 1, huh? 1 over 1, or just 1. Does that make sense? That's the purpose of the LCD. He's a hitman, taking out denominators. That way we have no more fractions. It's very nice. Okay, so what's the next? So now the fractions are gone, much easier. What do we do now with y's on the opposite sides? Get rid of the lower one, right? Get rid of one of them. So I'll just get rid of the 30y. Whatever you do to one side, do to the other. Boom. Bring this down. 24. This is 30y minus 1. I'm getting a little scribbly there. Good to there. What's next? Y wants to be alone. So we add 1. Remember, you're going to the letter y. He said, I want to be alone. So 30y is 26. Last step to get y alone. Oh, 25. I was testing you. Good. All right, I'm messing up. All right, there we go. So last step to get the y alone is divide. Remember, last step's always divide by the identical twin. Whatever's next to y, divide by the identical. So 25 over 30, that needs to be reduced, doesn't it? Divide by 5, divide by 5, 5/6. They're getting a little harder. This is a much harder section, 2.3. Is that good? And I got to get, so if that's too fast, I'm sorry. Okay, so minus 20 plus x is x. This is a really dumb question. Oh, dumb. Let me show you why. Okay, so I'm going to do this in quick. It's not important. I'm not going to put it on the test. What are you supposed to do? You got x's on opposite sides? What do you do?
Yeah, everything's gonna cancel.
Yeah, boom, boom. Minus 20. There's no more x. So when the x vanishes, there's two things it can be. If what's left is true, like minus 20 is minus 20, then that's all reals. That's what this one is, this option. If what's left is false, like if you have minus 20 is 18 or something, then that's no solution. Well, you can remember that. No, I'm not going to put this on the test. But there's the deal. So when the x's vanish, it's all or nothing, basically. How do you know which one? If it's true, it's all. If it's not true, it's nothing. No truth, no solution. This one is all true. What that means is any number will make that true. X could be anything to make that true. X could be 5. It's true. X could be 4. It's true. X could be 3. It works. It doesn't matter. So 22, 3 bracket. All right, there we go. The awful and the terrible. I'm going to whip through this one because I want to also show you 15, and then we'll be done. So here's the wall. What's first? These little parentheses. Distribute in here. So minus 3 times 4 is minus 12. Minus 3 times minus b is plus 3b. Everybody see that? They're trying to sucker you into subtracting 5 minus 3 first and getting 2. Don't bite at that baited hook. Right? They'll pull you out of the water and have you for lunch. Don't subtract 5 minus 3. Remember, adding, subtracting last. Just forget about PEMDAS. Just remember, adding, subtracting last, and you'll be safe. Don't subtract. Don't add until everything else is done. Adding, subtracting, last. They're trying to sucker you right there. Don't bite. Instead, you got to multiply. That comes before adding, subtracting. Same thing over here. Multiply. 15b minus 12 plus 2. Good to there. Now, I'm going to keep going here.
Did you combine like terms?
5 minus 12, exactly. Minus 7 plus 3b. Same thing here. 15b minus 12 plus 2 is minus 10. Good to there. Now we're going to need to distribute from the outside. The 3, boom, boom. Minus 21 plus 9b. And boom, boom. 75b minus 50. See how the brackets dropped off? Because I let something, the floodgates came down, water from the outside went in. Combined like terms, minus 21 minus 5 is minus 26. And minus 50 minus 26 is minus 76. Good to there. Now, what am I supposed to do at this point?
Minus 92.
Good. We have the letter on opposite sides. What do we always do when the letter's on opposite sides? Get rid of the lower one. So subtract 9b from both sides. Minus, what was my 66b, I think?
Yes.
We're close. See that? Now, B said, I won't be alone. I won't be alone. Get rid of this stuff that's with me so I can be alone.
Add the 76.
Add the 76. So that's gone. I'm running out of room. I have to bring it over here. That'd be 76 minus 26 is a nice, clean 50. And the other side is 66b, right?
Mm-hmm.
Last step. Divide by 66. And the answer is 50 over 66, but that has to be reduced.
25 over 33.
Yeah, so many steps. Yeah, so last step I'm bringing over here, I guess. 50 over 66, divide by 2, top and bottom. 25 33rds. Question?
You have 50 equals 66B.
Last step is always to divide by exactly what's next to the letter. Right, identical twin?
Oh, so B equals 25.
But over 66
Okay.
on both sides?
Oh, over here too. Okay, so this one.
Both sides, yeah.
This is B. And this, so.
That was a bad one. All right, well, we don't have time to go back, so we'll